All right, let's go over this graphing thing. And the whole idea here is to use that vertical horizontal shift technique for A and B. And for C, we're going to use the symmetric properties of parabolas to be able to graph C. All right, so let's go through and do each of these three graphs. The idea is to be quick and easy. The idea was not to use your graphing calculator. Okay? Now, remember our parent graph? Our parent graph is y equals x squared. And just so you know, it's a pretty cool thing. I obviously, look, when I was your age, I hated math. When I got older, I loved math. And one of the reasons I learned to love math is because I was looking to see if there's any structure or design or order in the universe. Is there anything that suggests that there's like a system in place, a design in place for what's going on? And one of the areas you can look for design all over the place is mathematics, and also science will also show you that there's a design. But if we take the squares of numbers, 0, 1 squared is 1, 2 squared is 4, 3 squared is 3 squared is 9, 4 squared is 16, 5 squared is 6 squared, 7 squared. All right, and it does keep going forever and ever. And if you look at the differences, it's 1, 3, 5, 7, 9, 11, 13. In other words, I take the squares of the numbers, and then I look for the differences in the squares of the numbers, and I generate the odd numbers. Okay, this is called first differences. And then you could go a little further and realize that then the differences between all of them are the even number base, which is 2, right? Because the difference is 2, 2, 2, 2, 2, all the way down. And I find it impossible to believe that that happened by accident. There's no way. It's far too coincidental for that to be an accident in any way, shape, or form. Now, what I want you to remember out of this, and the reason I bring it up is, if you notice, to go from one term to the next term to the next term, you go up 1, then 3, then 5, and so on and so forth, okay? So because I know that, I can come over here and go like this. Up 1, up 3, up 5, and so on, okay? So that's how I know exactly what points I'm going to be on. Now, clearly, if I multiply it by 2, like in the first one, then everything doubles. And instead of it being 1, 3, 5, it would be 2, 6, 10. Now, as I look at this, letter A, what is the horizontal shift? Come on, work with me here. Horizontal shift. Yesterday we talked about y equals a times x minus h squared plus k. Was k horizontal shift? No, what was k? Vertical shift. Where can I find the horizontal shift? Everybody? In the parentheses. What's in the parentheses? 3. Do I go 3 to the right or do I go 3 to the left? 3 to the right. We reverse it in parentheses. Remember we went over that yesterday? So that means I'm going to move 3 to the right. That's my horizontal shift. And then how many am I going to move in where for the vertical shift?
Up 5.
Up 5. So I go 3 to the right. 1, 2, 3, up 5. 1, 2, 3, 4, 5. And then I just repeat the same pattern. Oh, no, this is a 2. I'm sorry. So I go up twice as fast. And there it is. And remember we talked yesterday about the importance of the 2, meaning that it would get skinnier faster? Does everybody remember that? Okay. So that's an example of how quickly you can graph a parabola just by using vertical and horizontal shift, coupled with the fact that that A in front is a number greater than 1, which means the parabola gets a little bit extra skinny. Okay? Any questions? All right, now let's take a look at the next one. Letter B. When I take a look at letter B, and you do realize this is all last night's homework, right? As I take a look at letter B, the first thing I see is a negative in front. What does that negative do to the graph? Right, flips it upside down, makes it frown? Okay. Now, what I notice here is that I don't have it written in horizontal vertical form. Okay? So that means that I now need to find the axis of symmetry and the turning point. And we talked about the axis of symmetry before vacation. I know that's a long time ago. But x equals negative b over 2a. It's the formula for axis of symmetry. There were two questions on last night's homework. This one and another one that we'll go over in a minute that asked you to make sure you remember the axis of symmetry. So x equals negative 4 over 2 times negative 1 is negative 2. So x equals 2. Now if I want to go figure out the y to get the vertex, because this is the axis of symmetry, means that the graph is on the line of x equals 2. Now if I plug in the 2 coordinate, I'll find out the y, or the 2 part of the coordinate. So I plug in the 2. 2 squared is 4. Negate it, negative 4. 4 times 2 is 8, so I have negative 4 plus 8 is 4. 4 minus 3 is 1. So I go to 2, 1. There's my point. And using that same 1, 3, 5 deal, there's my graph. So, the red one was an example of how to graph using vertical and horizontal shift. The blue one is a reminder of how to use the axis of symmetry and then plug the x back in for here and here to compute the y value, and that gives me a vertex or a turning point of 2, 1. And the last one to do is y equals x plus 6, x minus 4, and then if I use the reversing properties in finding the roots would work out to be negative 6 and 4. Agree? So let's go to negative 6. 1, 2, 3, 4, 5, 6. And then let's go to 4. 1, 2, 3, 4. And the axis of symmetry will be midway in between. What's midway between negative 6 and positive 4? Let's see here. If I add them up, I'm going to get negative 2 and divide by 2, and I get negative 1. So here's my graph. Let's make sure. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. So my axis of symmetry is right there. Now I'm going to do the same thing with plugging in the negative 1. What's negative 1 plus 6? Positive 5. And what's negative 1 minus 4? That'll be negative 5 again. So that gives me a total of negative 25. So the axis of symmetry, I should say, the vertex is way down, which on your page there's a lot lower in your graph. I don't have it on the board here. So we would just make the axis of the turning point vertex, I don't know why I keep saying that, negative 1 comma negative 25, and then draw the graph. So 3 things we need to know. Vertical horizontal shift, axis of symmetry, find the vertex, and if I plot 2 roots, the axis of symmetry will be right in the middle of those 2 roots. If you understand those 3 things and can use them to see what the parabola should look like, you understand the last week's worth of work. Okay? Yes?
How did you find the axis of symmetry on the
I have to split it in half. Everything about a parabola is symmetric. If I draw any parabola, it's always even on both sides. Agree? So, if this is a root, and this is a root, then the axis of symmetry has to be in the middle between them. And then I just split the difference. Now, what I did in my head is I added up 6 and negative 4, and then I divided it by, I added up the roots, negative 6 and 4, that's what these numbers are, and then I divided by 2. And then just to check myself, I said, how far is this one? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They're both 5 units away. Okay? Any other questions? All right, so now let's rocket through some stuff that I wrote out for you. Okay, take a look at number 6 from last night. See how you did. We looking good? Okay. Again, to me, that's not as hard as it could possibly be, but that's plenty hard. And I would think that if they gave you a 4-point quadratic equation on the regions to solve, that's an appropriate level of difficulty. If they gave you a 6-pointer, I think it would be a little bit harder than that. Not that it should be, but that history suggests it will be. All right, so now we get to this particular part of the graph. and it starts talking about find the number of real solutions for each quadratic equation. And what I want to focus on is what graphs look like. The solutions are also known as the zeros. They're also known as the roots. How do you find the roots? By looking at a graph where it crosses the x-axis. Good. So how many roots does this guy have? 1. There it is, right there. How many roots does this guy have? 2. How many roots does this guy have? 0, because the x-axis is right here. How many roots does this guy have? 1. Now let's go a step further and see exactly what these roots are. The root of this one is 0. This one has no roots. This one, I don't know what the roots are. It's somewhere between 1 and 2 and -1 and -2. And this one, the root itself is 2. Agree? Okay. Now, let's go and take a look at these first two here, and all you need to do is graph them. If you were to graph them, this one would touch twice. Ivy head in the game. And if you were to graph this one, it would touch once. So, the first point I want these questions to bring out is that roots and zeros are the same thing. You can find them by how many times they cross the x-axis. But there's another part of this that's very important. We could use the quadratic formula. We're not going to, but we could. And in the quadratic formula, doesn't it make sense that every single time this part of the formula is going to be a fraction? Right? Does that make sense, everybody? Obviously. But what's under this radical is a hugely important thing. For instance, what if there's a 0 under the radical? What is the square root of 0? 0. What is whatever this fraction is plus 0, and then whatever it is fraction is minus 0? Aren't those the two same answers? So, since if you add plus 0 to the thing, and you get one answer, and then you add minus 0 to the thing, and you get the exact same answer, that is a picture of this graph and this graph. We know here, this piece here is called a discriminant. Discriminant. And we know that the discriminant here had to be 0, and it had to be 0 here, because there's only one root. And if there's only one root, the thing under the radical had to be a 0. So that, let's say this fraction works out to be 5/7, I don't care, whatever it is. Then I would get plus 0 and minus 0, that answer would be the same. Do we all agree? Now, if this was any number other than 0, would the answers be the same? No. So as soon as I look at this, I know that there's no way a 0 is under that radical, because I got two different answers. Next, this one doesn't even touch the x-axis. What kind of number has to be under the radical for that to happen? We did hint at this once or twice. What? Nope, not a 1. Because square root of 1 would be 1, and then you go plus 1 and minus 1, and that would give you two answers, so it might look like this. No, a negative. Everybody take your calculator and do the square root of -5. Square root, -5. What does it tell you?
It says error.
It says error. Because there is, in the real number system, no square root of -5. Since there's no square root, there can't be a root. If there's no roots, you can't touch the axis. So this is a picture of the square root of a negative. Okay? So by looking at the pictures, I can actually figure out what that discriminant has to look like. Here, the discriminant had to be 0. Here, the discriminant had to be 0. Here, the discriminant had to be negative. And then finally, what if, now there's two other possibilities, that square root could be a number like 25 or 100, or it could be a number like 71. What's the difference in those three? One is different than the other two. Which is different and why? Alex?
100 is easily square rooted.
So is 25. What's square root of 25, everybody? 5. What's square root of 100, everybody? 10. What's square root of 71?
A weird decimal number.
Yeah, it's an irrational number. It goes on forever and ever and ever. So what we learn is that when it comes to roots, if there's two roots, they could be rational, they could be irrational. I can't tell that by looking at the picture. But I do know that there has to be a number under the radical, other than 0. And Then I look at the roots and I see, do they come out to be like some really long, ugly decimal? Then it's irrational. And if it comes out to a whole number, then it works out to be a rational number. Okay? All right, so we've talked about the nature of the roots. We've talked about what different ways to graph and understandings of symmetry and so on and so forth. And now we're going to take some more ideas about graphing parabolas and put them together. So was this the do it, I think? Y equals x squared minus 6x plus 5. Identify the key features. Now, anytime you do a graph of a parabola or anything else on a calculator and you use your calculator, you should write the table in. So that's 6 over 2 is 3, 2, 1, 0, 4, 5, 6. This is 0, 5, so it would be 6, 5. 1 would be 0, 5 would be 0. 2 would be 4 minus 12 plus that's negative 3, and that's negative 4. So there's my coordinates if you did it in your graphing calculator. Okay? And let's graph this guy. 0, 5. 0, 1, 2, 3, 4, 5. And then we have 1, 0. Then we have 2, negative 3, negative 4, here, here, and here. What a beautiful graph. And then it says something strange. It says identify key features. So now what we're going to do is just look at the graph and talk about things that we notice about the graph. Who wants to say one key feature? Come on, help me out, go ahead.
It's positive.
Okay, the first coefficient has to be a positive x squared. It's a smiley. Positive x squared, good. Tell me something else about it. Come on, talk to me. Emma. The vertex is 3, negative 4, right? Vertex is 3, negative 4. Good, more. Tell me other key characteristics of this graph. Allie, tell me something on this graph that you notice. What? That's too simple. Keep going, what else? What?
Zeros are 5 and 1.
Excellent, the zeros are 5 and 1. What's another word for zeros? Roots, good. What else do you notice? Perhaps an axis of symmetry? Anybody notice that? Ivy?
3.
No, not 3. Be a little more specific. X equals 3. Axis of symmetry is always a line, and a vertical line is the only line that begins with x equals. So the axis of symmetry is x is equal to 3. Now, the next thing I want to mention too is over what interval is this parabola or is the function increasing? Over what interval is it increasing? Well, first let me ask, does it have a maximum or a minimum? Minimum, right? It's bottom. So minimum is when it's getting bigger. Or I should say increasing is when it's getting bigger from the minimum. Where does it start to get bigger from the minimum? Emma?
3.
Okay, so any point from 3 on, it's increasing. And we would write that, we could do it a couple of different ways. I could write 3 is less than x is less than infinity, or I could do the parenthesis notation, right? Okay, over what interval is it decreasing? Talk to me, what interval is it decreasing? 3 is an important point, but it's not an interval. Where does it start to increase?
3.
No, that's where it stops. Pardon me. You were right. I said where does it start to increase. I should have said where does it start to decrease. 3 is where it stops decreasing. Where does it start decreasing? That way, right? Is there a specific place where it starts to decrease? No, it's all the way out there. So we would say that would be negative infinity to 3. Okay? So those are all key characteristics of that particular parabola.
I'm really bad at lines.
Okay? Any questions? Okay. Let's go to the next one.
Yeah.
Graph it on your calculator. Go ahead.
On the calculator?
On the calculator. Remember, if you're gonna graph it, then you wanna actually put the table on the side of the graph. It's very important to put that table down there, and I'll tell you why it's so important. Let's say you're taking your Regents exam, and let's say you do something which is completely understandable, but at the same time very stupid, and instead of typing x squared plus 5x plus 6, you type x squared plus 4x plus 6. The kind of mistake that people can make, or maybe plus 8x, because the 8's above the 5. And then you do this beautiful graph of what you thought the equation was with that sloppy mistake, you would get 0 points. But if you put the table on the side, and we saw that the points you graphed matched the table, you would get half credit. So you want to make sure you put that table down there. Do not leave the table out. Okay? Okay. Now, take a look, because I'd rather get through a little bit of work here than slow too much down. I do see some people with the graph completely finished. First off, remember the number one thing I said I do not want you to do whenever it comes to graphing a problem? I said I don't want you to be like the cartoon painter who holds your finger up and just kind of sketches where it should be. We want to use that table. So, to get the table, I go to second table, and I scroll up and down the table until I find the part where I see the symmetry that we've been working so hard with. The -2's match up, the -4's and a halves, the -6's. When I see that part of the table, that says to me, okay, those are the points I graph. Now, here's what my graph looks like. And now we get into some key characteristics of this graph. First off, what is the axis of symmetry? Can anybody tell by looking at the graph what the axis of symmetry is? Or is it a little tough to tell? If I were you, I would think it's a little tough to tell, no? Right? How many people feel it's a little tough to tell by looking at the graph? Right? Yeah, we got some hands up. Good. Go to the table. Second table. What number's in the middle there that everything pairs up around? Or what coordinates, I should say? -5, comma what? -6 and a half. So guess what? That's your vertex. -5, comma -6.5 is your vertex. Now, given that that's the vertex, what is the axis of symmetry? Sammy?
X equals -5.
Perfect. So x equals -5, because the axis of symmetry is always x equals. And the vertex is -5, -6.5. Good. Over what interval is this particular function increasing? Over what interval is it increasing?
-5.
To infinity, and you would write that with parentheses, or not equal symbols, just use less than symbols. What's that?
Do you just write that on the graph somewhere?
Yeah, you can put it anywhere you want on your paper. I think the directions just say write key characteristics. Over what interval is it decreasing? Yeah, negative infinity to -5. Okay, good. Let me ask you a question. On the discriminant, remember the quadratic formula, that radical, that's what we call the discriminant? Is the discriminant negative? Is the discriminant negative? Maya, why not? That is not the right explanation. Who can tell if, well, I'll give you a hint. It is a negative discriminant. I'm sorry, it's not a negative discriminant. How do you know it's not a negative discriminant? Remember what we did before. We said if the discriminant is 0, in other words, if the number under the radical is 0, then there's one root, remember? Let's do discriminant, roots, number of roots, and then what the graph would look like. So this graph would look like this. It would touch in only one place because there's only one root, agree? And then we said if it was the square root of a negative, how many roots were there? No, there were none. Remember what happened when we put the square root of a negative into your calculator? What did it say? Error. So there are no roots that way, and the graph, if you remember, looked like either of these. The bottom line is the graph didn't touch. Does that graph touch?
Yeah.
Yes. Now, is it possible for this to be a negative discriminant? No. Now, is it possible for the discriminant to be 0? No, because then it would touch only once. I don't know if that discriminant is a perfect root, like say 25, or an imperfect root, like let's say 27. I can't tell that. But I do know that there's a number under the radical that's not 0 and it's not negative. Okay. We did increasing, we did decreasing, we did vertex, we did turning point. I can't tell the roots. The reason I can't tell the roots is if I look at my table, is there any place on the table where it says 0? No. And if you look on this, isn't it pretty obvious that we don't pass through a perfect point? Right? So I don't know what the roots are by looking at the table. Okay. Next one. Paige wants to start a summer lawn mowing business. She comes up with the following profit function that relates the total profit to the rate she charges for a lawn mowing job, blah, 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 blah. Both profit and her rate are measured in dollars. Graph the function and then answer the questions. Go ahead, graph it. And you don't have to copy the graph onto your paper. Just graph it and then answer the questions by looking at the graph on your calculator. Or your calculator. Do you not have a calculator? You're welcome to use one. It's okay. Are you gonna like look on hers? That's what you would do? I'm surprised you don't like slide over right next to her, put your arm around her, go, hey buddy, pal. You guys notice that you get a window that pops up? Well, your Zoom 6 window is not gonna cut it. Okay, so, let's play. This guy here, it crosses at 3, and it's going up when it crosses. So, I'm gonna go with the x from -1, and, I don't know. I'm just gonna try a few different numbers and see if I can get it. So I'll go to window, I'll go -1 here. I don't like to start at 0 because I like a little room on the left. The x maximum, it's gotta be bigger than 10 because it didn't fit in 10. So I'll go to 20. And the y scale, I could go -10, I don't really care. But it's obviously way taller. So I'm gonna go with, say, 250.
300.
Is it 300? And then let's hit the graph and see what we get. Wow, I gotta go way past 20 and I gotta go way past 200. So window, I'm gonna go to 45, and I'm gonna go to 450. Graph. There we go, now I'm looking good. Okay, so, this then starts asking a few questions. What is the first question? Come on, talk to me. What's the first question say on your paper?
What was her initial cost?
What's the initial cost? $100. I know that because what is the value when x is 0? -100. So the initial cost is $100 because I'm $100 in the hole. Okay, good. What's the next question? And by the way, I can also do that by looking at my table. If I go to second table, my initial cost is when time is 0. And at time 0, I'm down 100. Okay? Good. What's the next part? Sam, what's the next question?
Between what two prices does she have to charge to make?
Okay. Isn't it pretty obvious that it's profit if the output is positive? We agree with that, right? So I'm going to look on the table until I get to where the profit is positive. Now these are all negative, so I gotta keep going this way. Oh, look at that. So if I sell more than 2 So I can't sell like 2 point something, so if I go from 3 to I can't go too fast here, it'll just keep going. So that's why I'm taking my time with this. Is it 37?
Yeah.
Okay, so from 3 to 37, you make a profit. If you sell more than 37, you actually lose money on the deal. And if you sell less than 3, you lose money. But from 3 to 37, you make a profit. Okay, what's the next question?
If she wants to make 275 profit this summer.
Okay, how many do you have to sell to make 275? Ready? Go to the table, and let's find 275 for the profit number. There's probably two numbers that match up with 275. Yeah, so one of them's 25, and what's the other one? 15? Is that what you said, 15? Okay, so 15 and 25. I want to do one other thing and make sure you know how to do this on the calculator. This is the last thing we'll do for today. What's the maximum amount of money you can make? There's two ways to figure it out. What's the most money you can make? $300. You can look at the maximum. Very good. But there's another way to do maximum. Ready? Don't pack up. This is very important to know. Take a look. I'm going to go second, calc, and you see how it says maximum? Choice 4. Now, remember we did the little blink and bug yesterday? Left bound, enter. Right bound, enter. Guess, enter, and it will tell you the value. So,
Julia Tax to return 5.
hasta la vista, vaya con Dios.